Hi guys, today I'll be going through this question, balancing a binary tree. So we are given a binary tree and we want to balance the tree. So basically if the binary tree is out of balance, we want to balance this tree. Okay, so let's say given a binary tree something like this, we want to store the binary tree in an in order format. So it's something like left, root, right. So by storing in this in order format, it's gonna give the array in ascending order, something like this, which is what we wanted. Yep. So yeah, let's create the array, which is vector. So if the root does not exist, we just want to return null, which is the root. Okay, so let's put the root inside the in order. After putting the root inside the in order, we want to build the tree. If the root does not exist, we just want to return. Okay, so there's we want to the root in order left, root left, and in order root right. So for this part, we're going to store the root into this array dot pushback root. So it's done. And after we store the binary tree inside the array in an ascending order, we want to build a tree. So the way we want to build the tree is when we store the binary tree in ascending order, we first want to find the middle, which might be 12. So 12 is going to be the root. The left side is going to be somewhere here. The right side is going to be somewhere here. Yeah. And we'll build something like this. And it's going to be balanced. A binary search tree. Yeah. Okay, so we need to pass in the start and the end. Int size equals to root dot size. In order dot size. size -1. We want to return node, so it's gonna be build tree, and int start, int end. If the start is greater than n, we just want to return now. And when we build the tree, we want to build it in the pre-order format. Pre-order, which is root, left, right. Yeah, so the root is coming first. Root, oh wait, so we first have to find the middle. Int mid equals to start and my start divided by 2, and in order mid, so this will be the middle. Root left equals to build tree, start mid -1, root right equals to build tree, start, oh wait, mid +1, and yeah. So this part is just basically saying that once we have the root, we want to, let me just write this out again. This part, basically after we get the middle, we want to, the root left is gonna be from the start to the middle -1. So it's gonna be here, this part. And the root right is gonna be mid +1, which is from 13 to 19 to the very end. And it's gonna call recursively until it reaches this part, the base node. And at the very end, we just want to return root. So that's how we balance a binary search tree. I think if everything's right. Oh yeah. Yeah, thanks for watching. See ya.